Okay, so now we're going to get to the last part of this chapter and solving trigonometric equations using identities. So we've solved trigonometric equations before, that's nothing too new to you guys, but now we're going to solve using identities, which makes it a little bit more complicated. Now, one thing that I'm going to bring up for this course, if we scroll down here, and you guys will see solving equations using multiple angles. So you see the sine 3x, cos 2x, sine 1 over 2x. We are not going to do that here. You don't have to worry about that for Alberta curriculum, though it is very, very good to know. But we're not going to look at that right now. One other very, very important thing that I want to bring up is you'll notice I said we're not going to do something like cos 2x. But when I scroll back up here and we look at our first example, or the second example, you'll see that I have the sine 2x and the cos 2x right there. We are going to do ones like this because all these mean is that we're going to use an identity to substitute in. We're not actually solving a multiple angle equation. Okay, so don't worry about the multiple angle equations, but you will be responsible for solving ones that have the identity involved right here. So starting off, I have sine 2x minus cos or minus 2 cos x equals 0. So my sine 2x is going to become 2 sine x cos x minus 2 cos x, and we have that equals 0. From here, I notice that between both of these, I have the 2 and I have the cos x. So I'm just going to factor it out. And I get 2 cos x bracket sine x minus 1 equals 0. Now at this point right here, well, if I have something multiplied by something equals 0, that tells me that one equals 0 or the other equals 0. So I get 2 cos x equals 0, meaning cos x equals 0, or I get sine x minus 1 equals 0, which means that sine x equals 1. Now we look and we see that my domain is from 0 to 2 pi. So this again just becomes one of the unit circle things. I'm looking for where cos x equals 0 and where sine x equals 1. So that means that my solutions are just going to be x equals pi by 2 and x equals 3 pi by 2. Again, very, very important. My question was given in terms of radians, so my answer is going to be given in terms of radians. Now I have 4 minus 7 sine x equals cos 2x. Now, looking at that cos 2x, well, which one of the substitutions am I going to use? The rest of my question is given in terms of sine x. So that means I'm going to use the substitution that has a sine x involved, which will give me 4 minus 7 sine x equals 1 minus 2 sine squared x. Now, from previous lessons, when we were looking at this, especially in chapter 4, you see that I have that 2 sine squared x, and realistically, this is just going to model what a quadratic is. So I move everything over to one side and equate it to 0, which will give me 2 sine squared x minus 7 sine x plus 3 equals 0. And again, because I'm solving an equation, I can switch sides again. Now, if you guys are having problems visualizing what we do next, this is pretty much the exact same as saying 2x squared minus 7x plus 3 equals 0. So just quickly going off on the side right here, if I have 2x squared minus 7x plus 3 equals 0, we want to factor this. The a times c would equal 6, and my b value equals negative 7. So I'm looking for two numbers that multiply out to positive 6 and add up to negative 7, which would give me negative 6 and negative 1. So I get 2x squared minus 6x minus x plus 3 equals 0. I'd factor the 2x. I would factor the 2x out of my first two terms, which would leave me with x minus 3, and I'd factor the negative 1 out of the second two, which would leave me with the x minus 3, and this would leave me with 2x minus 1, x minus 3 equals 0. Going back to my equation, that means that 2 sine x minus 1 multiplied by sine x minus 3 would equal 0. So that would tell me right here that sine x would equal 1 over 2, or sine x would equal 3. From our sinusoidals unit, we remember that sine x can never equal 3. It's bounded above by positive 1 and bounded below by negative 1. So therefore, we get that x equals pi by 6 and 5 pi by 6, looking at our unit circle for where sine x is going to be equal to 1 over 2. Moving on